If you've ever made drinks like iced tea from powdered drink mixes, you know that the amounts of powder and water are always mixed in the same ratio. For example, to double the amount of iced tea without changing the taste, both the amount of water and the amount of powder must be doubled. To make half the amount, both the amount of water and the amount of powder must be halved. Now that's pretty straightforward as long as I'm doubling or halving. But what happens when I want to compare two different ratios for the same drink? Let's look at this problem. Suppose I have two different recipes for iced tea. Recipe A calls for 3 scoops of powder to 5 cups of water. Recipe B calls for 2 scoops of powder to 3 cups of water. Recipe A makes more iced tea because it uses 5 cups of water. But which recipe will give the stronger tasting drink? Why don't you make a prediction? Which recipe do you think will give the stronger tasting drink? There are a couple things to consider. I know that more water could mean a weaker drink. I also know that more powder could mean a stronger drink. It's the same recipe. What am I going to do? Let's work with the numbers to find out. In recipe A, the ratio of powder to water is 3 to 5. We write that as 3 to 5. In recipe B, the ratio of powder to water is 2 to 3. We write that as 2 to 3. Okay, so just to remind ourselves, our ratios here represent the amount of powder to water in each recipe. It's difficult to compare these ratios because the terms that represent the amount of powder are not the same, and the terms that represent the amount of water are not the same either. It sure would be a lot easier if each recipe called for the same amount of powder. Let's see if we can make that happen. Let's write each ratio with the same first term. The first terms are 3 and 2. A common multiple of 3 and 2 is 6. Multiply the term in the first ratio by 2, and the term in the second ratio by 3. But since we multiplied the first terms, we have to do the exact same thing to the second terms in each ratio. So that means I'm going to have to multiply this 5 by 2 as well. That's going to give me a new ratio of 6 to 10 for recipe A. And over here, since I'm multiplying the 3 by 3, that's going to give me a ratio of 6 to 9. Let's compare the ratios. Both recipes use the same amount of powder. Recipe B uses less water than recipe A. So recipe B gives the stronger drink. What if we had written each ratio so that each recipe uses the same amount of water? Would we make the same conclusion? Let's see. So our original ratios were 3 to 5, and 2 to 3, remembering it represents powder to water. And I'm going to draw this line all the way across, just so I remember that I'm starting new. Now the second term in each ratio represents the amount of water. Let's write each ratio with the same second term. The second terms are 5 and 3. A common multiple for 5 and 3 is 15. Multiply the term in the first ratio by 3 to get 15, and the term in the second ratio by 5. That gave me 15 there. So I know that I have to do the same thing to the first terms. So since I multiplied by 3 here, I have to multiply 3 by 3, and that gives me 9. Over here, since I multiplied by 5, I have to multiply the 2 by 5, and that gives me 10. Now let's compare the ratios. Both recipes use the same amount of water. Recipe B uses more powder, so recipe B gives the stronger drink. So to compare two ratios, we use common multiples to write equivalent ratios, so that the ratios then have the same first term or the same second term.